Question 1 says a force of 19.5 Newton applied parallel to the surface of a horizontal table is just sufficient to make a block of mass 2 kg move on the table. Calculate the coefficient of friction between the block and the table. So this is the block on the horizontal table, right? The block is just 2 kg. Down the block towards the center of the earth lies the weight, and the weight is mg, and multiplied by the acceleration due to gravity 10, which is giving us 20 newtons, right? Opposite the weight is a normal reaction. The normal reaction is facing upwards. It's also equal to 20 newtons, because normal reaction is a force on its own, which is still equal to mass times acceleration. So for a plane like this that is not inclined, the weight is always equal to the normal reaction. So when the weight is 20 newtons, the normal reaction will be 20. When the weight is 50 newtons, the normal reaction would also be 50 newtons. So towards a side of the block of 2 kg lies your force, the force in motion, right? Now, once you place your force here, moving towards this direction, opposite it must be your frictional force, because in our previous video we said that friction is that which opposes motion, right? And the motion we're talking about is the force in motion, right? So if that is gotten, we can solve this question. Since we are asked to find just the coefficient of friction, we can solve this problem using a simple method, provided we know what we're actually dealing with. So I can say that my force is equal to, that is, my frictional force is equal to coefficient of friction times normal reaction. So my coefficient of friction will be equal to frictional force over normal reaction, right? So what's my frictional force? The frictional force is not actually given. Does that make sense? But I know that at every point in time, when the force is just sufficient to move a block, it means that the force is just equal to the frictional force. So I can assume that my force in motion is equivalent to or the same as the frictional force. Therefore, what am I going to have? I'm going to have my mu, since the force in motion is equivalent to it, I can have my mu to be the same as 19.5, right, over my normal reaction is 20. That would give you, can you get that? That would give you 0.975, right, without units, because this is a Newton, this is a Newton, so it cancels out, right? But there's another way we can solve this question in a more explanatory form. So, which approach is that? We're going to look at the area of the second equation of motion according to Newton, right? What is this saying? It's saying F equals to ma. This F is your net force, right? And what's the net force saying? It's saying the addition of the forces on each axis. So for this axis, which is your Fx axis, that's your x-axis, you have two forces, your frictional force and your force in motion. So for your y-axis, you have two forces, your normal reaction and your weight, right? So considering the angle here, our mu is, right? So that's the coefficient of friction, right? That's what I'm calling the mu. You have the total force now, or your net force, would be F minus Fr, everything to be equal to this ma. So the whole of this F minus Fr is just signifying this, right? So it is the sum of the two. I took the subtraction as the difference because they are vectors on opposite direction, right? So and vectors on opposite direction, you have to subtract the vector. Now the question is, why did I place the force in motion first before the frictional force? Right? I should have written it as Fr minus F equals to ma. Why did I do this instead? So I did this because my force is assumed to be greater than the frictional force, because the question says that the force is sufficient, it's just sufficient, right, to move the block, which means that it is at that point the force in motion is equal or greater than the frictional force. Do you understand now? So if that is done, I have my F to now be equal to 19.5 minus my mu r, right, equals to ma. So my a here will be your acceleration, because the question never says that acceleration is given as any value. Hence, I could take my acceleration to be equal to 0, because the body is not accelerating. The body is not said to be accelerating, right? So everything here, I have m and 0. Everything here gives me 0. So I have 19.5 minus mu r. So I have my mu will be equal to 19.5 over r, and my r is said to be 20. So I have 19.5 over 20. That will still give me 0.975, right? No units, because these are all in newtons, which will end up canceling out. So if that's the case, let's move to our next question. So let me reduce that for you in case you want to take a screenshot. So we have the next question here. The next question says that a block, drop this down, a block weighing 21 newtons rests on a flat surface, and a horizontal force of 12 newtons is exerted on it, right? So let's quickly have the horizontal surface, right? So if this is our horizontal surface, the block is this. The block is weighing, we're giving the weight direct. So if we take G to be, if we take G to be 10 meters per second square, we're going to have the mass of the block to be 2.1 kg. But don't assume that, just leave it like that, right? So we have our normal reaction, R will be equal to 21 because for this plane, it is not inclined. Hence, R is equivalent to W, or W is equivalent to R. But don't forget that our horizontal force applied to it is the force in motion, and it is equal to 12 newtons. Now, the question says, determine the frictional force, and don't forget the frictional force is equal to mu r, right? These are all the components you are expecting. Between the block and the surface also is your mu, but you're not looking for all of this, right? So you're looking for the frictional force. Now, you don't have your mu to solve for the FR. So by imputing your R here, you still need your mu, and there's no any other way to get your mu. It tells you directly that the answer is 12 because your force in motion would be equivalent to what? Your frictional force. Hence, since your acceleration is not given, so if I would apply the second Newton equation of motion, I'm going to have F equals to ma. Don't forget, this is still the net force. So if that's the case, what am I expecting? I'm expecting F minus Fr equals to ma. Here my acceleration is equal to 0. I'm going to R, where acceleration is 0. I'm going to have my force to be equal to my frictional force. So if my force is 12 newtons, my frictional force is going to be 12 newtons. You get that? So this is my answer. Therefore, Fr is equal to 12 newtons. Don't forget, we need all of the 0, and that's why we have it to be equal to this. So let's quickly take the next question. The next question says that a concrete block of mass 35 kg is pulled. A concrete block of mass 35 kg is pulled. The mass is 35 kg, don't forget, is pulled along the horizontal floor with the aid of a rope. It's pulled along the horizontal floor with the aid of a rope, but the rope is inclined at 30 degrees, right? So we have this. This is the horizontal floor. This is the mass. Right? But there is a rope pulling it, right? And the rope is inclined at 30 degrees to the horizontal, right? So to the horizontal, if we were told that it is to the vertical, then you put the angle here. Does that make sense? So since I have my rope here, my rope to the horizontal, the angle of the rope to the horizontal, what is the force of the rope dragging it? We don't know, right? This is unknown, right? But you know the mass of the block to be 35 kg, right? So it means that the weight, it will be 35 times, because it's equal to mg, which is equal to 35 kg times 10 meters per second square, right? So that will give you 350, provided your G is 10 meters per second square. You may be given your G has 9.8. So opposite of weight is usually your normal reaction R. So don't forget that if the force is towards this area, the force dragging the object at an angle of 30 degrees is towards this area, then your frictional force would be Fr, and it must be opposite it. And don't forget, your frictional force is always equal to mu r. Now, this question cannot just be solved this way because your force is inclined. So what you're going to do is just to resolve this force not to be in between y and x, right? So you resolve to y-axis, then resolve this to x-axis. So if you don't know how to resolve, well, just check our video on resolution of forces. All right. If that's the case, resolving this to y-axis, I'm going to have f sine theta, right? That's sine 30 degrees. This I'm resolving it to the horizontal, so x-axis, and that's why I'm using cos. So I have f cos 30 degrees. Now, once you resolve, it is assumed that the force, this force here, would leave the system, So the force is no more on that part. Instead, it's acting on these two areas. So this is acting like this. This is acting this way. The normal reaction is acting this way. The weight is acting this way. At this point, weight is not equivalent to R. Why? Because the weight is going upwards and it must be equal to everything here together. So if weight is going to be 350 newtons, R must not be equal to 350 newtons, right? Must not be equal to 350 newtons. Why? Because this F sine theta is going to have a value of its own. And by the time you add it to that 350, if you take it to be 350, what will happen is that the value will be greater than 350, which means that W is going to be equal to R. Does that make sense? So in that sense, what we do is we say instead that W would be equal to R plus everything that's R. W will be equal to R and everything moving upwards, whose direction is upwards. You understand? Right. So this will be the formula relating R to W. Does that make sense? So from our Newton's equation of motion, I still have F equals to ma. That's second Newton's law, Newton's equation, right? So your F is still your net force. So for x-axis, for this axis, I have F cos theta degrees minus Fr, everything to be equal to ma. Note that acceleration is not given, so acceleration is equal to 0. So what am I going to have? I'm going to have F cos theta, right, to be equal to Fr. Now, your Fr is still the same as mu r, F cos theta, So this becomes your equation 1. And for this is your equation towards the fx axis. That is this, right? Now, you would need another equation for y-axis because the component of force you have to find has actually been shared into. That's your F here is showing on two axes, right? Your F here is showing here on x-axis, is also showing here on y-axis, right? And that is why you need the two equations from both axes to form what you need to get what you need, right? So we have W equals to R plus F sine theta, that's sine 30 degrees, right? Sine 30 degrees. That will give you your second equation. That is towards Fy axis. So this is your for your Fy axis, right? All right. If that is done, now we quickly solve each of those equations. So from equation 1, what am I going to have? So from equation 1, I'm going to have this F cos theta of 30 degrees equals mu r. Here I know that my mu is 0.75. So I have this to be 0.75 r. 0.75 r equals to F cos 30 degrees. Now note that whenever you are asked to find the force, you make R the subject of formula. Whenever you ask to find the normal reaction, you make F the subject of formula. So making R the subject formula, I'm going to have F cos theta, which is 30 degrees, over 0.75. So take the division of cos 30 degrees to 0.75. I'm going to get R equals 1.155 approximately. So I'm supposed to have 1.1547. So f, right? So this is my answer for r, but I have not gotten a fixed value for f. So substitute this that you've gotten, substitute if this is your equation 3, substitute equation or substitute 1.155 f for r in equation 2, right? So what am I going to have if I substitute that in equation 2? W equals to r plus f sine theta sine 30 degrees as our equation 2, right? So here W equals 350 and R is equals to 1.55 F, 1.155 F. What do we have? We have 350 equals 1.5155 F plus 0.5 F. So that will give us 1.655 F, everything to be equal to 350. F is going to give us 350 over 1.655. So what are we going to have? We're going to have 211.48, which is on approximation 211.5 newtons. And next question says a body of mass 15 kg rests on a rough inclined plane whose angle theta is variable. Theta is gradually increased until the body starts to slide, right? The plane at 30 degrees. So the mass is 15 degrees. Then our angle was first theta. So I have this. The body is resting on a rough inclined plane. So this is my inclined plane. So the body is resting here. So I have 15 kg. The angle was first theta until increased to 30 degrees, right? To 30 degrees. So what do I have? I'm asked to find the coefficient of friction. So the coefficient of friction is around this junction because it is found between the body and the surface, right? So I have component bringing body down is W, is the vertical component W sine theta. Since the body is sliding down and there is no any other force acting on it except this, right? Opposite the force will be your frictional force, Fr. And Fr is equals to mu r. Don't forget your horizontal component, W sine theta, right? So, and W cos theta, rather, and it is equal to your normal reaction R. Note that for this question, since the mass is 15 kg, it means that your weight will be equal to mg, and mg is telling you 15 times 10, provided that g is 10 meters per second. So you have 115 Newton. For the same question, note that W is not equal to R because it's an inclined plane. So here, W is not equal to 115 Newtons. That's what that's telling you, right? So to solve for mu, there are 3 methods I can solve this question with. So I can start with method 1, starting with my formula for mu. I know the mu is always equal to Fr over R. Note that your Fr is equivalent to this provided the body is not accelerating. So I have W sine theta over R is equal to this, right? Since the body is not accelerating horizontally, right? So we have W cos theta. What would that give me? That will give me mu to be equal to this, cancel this, right? So I have sine theta over cos theta. That will give me tan theta. So this is my theta. Okay, your theta is 30 degrees, right? So what am I going to have? I'll have tan 30 degrees, tan 30 degrees. That's going to give me 0.577. That's approximately 0.58. So that's my solution to this question. That's the first phase. So method 2 is for me to just to say mu is equal to tan theta. Tan theta, that will give me tan 30 degrees, right? That will give me 0.58. The last method 3, I will consider the diagram. We have two components on the diagram. Since you are asked to look for your mu, consider Fy axis. This is Fy axis. That is the forces on that axis, right? That plane. Now, for your Fx axis, right, have these forces, right? You can observe that this line and this line are almost the same because they are parallel, right? So this is your x-axis and the other is your y-axis. Does that make sense? All right. So considering that, according to the second equation of Newton, we have F equals to ma. Note that your F is your net force, right? Your net force, and that is telling you that the sum of forces or the differences of the difference between the two forces, right? So provided you have Fy, right? For Fy, we have W sine theta, since you have something like this, right? So you have the mass of block and this of sine theta, right? This is telling you your Fr, your frictional force. So you have minus Fr, everything to be equal to Ma. The whole of this represents this force, right? Now, we are subtracting because they are opposites in direction. Does that make sense? One is acting this way, one is trying to pull the block down, the body down, and the friction is acting opposite. Right. All right. So having that, we have acceleration is not given, hence acceleration is equal to 0. So we have W sine theta to be equals to Fr because the whole of this is going to give you 0 in the end. So I have W sine theta, theta, since theta is equals to 30 degrees, right? So we have equals to mu r. This would stand as my equation 1. Now for equation 2, we'll find that as fx, right? So fx is telling me that I have r, right, to be equals to w cos theta of theta, hence my r is equals to w cos 30 degrees. Cos 30 degrees. This is my equation 2. Why am I considering two equations for mu? Because I know that mu is as a result of fr over r. So it's as a result of two components. So here your fr is falling, right? Your fr is falling on this axis, and your r is falling on this axis. So it combines the two axes, this axis and this axis. Does that make sense? So in other words, mu is as a result of the two axes on the plane, right? If that's done, can I quickly compound this? This is method 3 continuation, right? Method 3 continuation. Can I easily compound this? So I have some equation 1, right? I have equation 1 to be w sine theta and 30 degrees equals to mu r. This is my equation 1. So can I substitute equation 2 into equation 1, having w sine 30 degrees equals to mu r. R is w cos 30 degrees. This is r here, lying down here, right? So I have w to cancel w. This mu. You cancel w. What am I going to have as my mu? Mu would be equals to sine 30 degrees, right, over cos 30 degrees. So that will give me sine 30 degrees. So it's still giving us back the sine 30. Tells us 0.58, right? That's that for this particular question. For this question, it says question of static friction between a 12 kg crate and a concrete surface is 0.25. Find the magnitude of the minimum force needed. So you're looking for the minimum force needed. Keep the crate stationary, right? Now, don't forget that the base of the concrete is inclined. And don't forget your crate is found on that concrete, is on the concrete, right? So have this concrete is inclined at 45 degrees, right? That's your theta, 45 degrees. And block is found on it, 12 kg. Coefficient of friction is 0.25, that's your mu, right? So for us to find the force, the minimum force that can keep the crate stationary, don't forget
the word stationary means they want the block or the crate to be on this particular place. They don't want it moving, right? So for us to do that, it's very simple. Get the components for the block. You have the vertical component Fy, which tells you W sine theta, right? And this is bringing the block downwards. You have your horizontal component, right, R, and it is directly proportional to W cos theta, and that is cos 45 degrees, right? Now, opposite this would be your frictional force, because anything that opposes movement downwards will be upwards, and that's your frictional force. Now, for us to keep the crate stationary, that is to remain at the same point, we need a force here that can keep the crate there, right there. But we have a force bringing it down, and we have another. So we need a balance. That's the meaning, right? So for us to get a balance between this and this, we need to subtract the two forces to get this, and that is the force that is minimum to keep the crate stationary. Does that make sense? All right. If that was the case, can we have our F, which is the force to keep the crate stationary, to be W sine theta minus FR, right? So I have W sine theta minus mu R, where you know from this axis, right? R equals to W cos theta, right? Their acceleration is equal to 0, and that's why R is equal to W cos theta, right? So we have F would be equal to W sine theta minus mu into bracket of W cos theta. Substitute the value. Now, don't forget your W. The W will be equal to 120 newtons, right? That's weight, because provided G is equal to 10 meters per second square, right? So what am I going to have? I'm going to have F to be equal to 120 sine 45 degrees minus my mu is 0.25 into bracket of 120 cos 45 degrees, right? That would give me 84.85 minus 0.25, right? 0.25 into bracket of 84.85, right? That would give me 84.85, right, minus 21.21, right? That's going to give me 63.6 minus 84.85, right? 63.63, right? Approximately 63.64 newtons. That will be my force, right? So the force that will keep this crate here, it would be 63.64 newtons, right? And that is the solution to this question.
Right. For this question, the question says a concrete block of mass 15 kg is pulled along the horizontal floor with the aid of a rope inclined as the rope is inclined at 35 degrees, not the surface upon which the mass 15 kg is resting. Does that make sense? So I have, this is the floor, right? And I have a mass of 15 kg resting on the floor. So I have 15 kg mass. Now the weight of the body resting will be equal to mg, right? Provided my g is equal to 10 meters per second square, right? If that is the case, I will have 150 newtons here, right? My R would remain R here. Now, the question says that it is pulled with the aid of a rope. So the force acting on this, pulling it to this area, is inclined to the horizontal, right, at 35 degrees. At 35 degrees. So this is a force, but the force is not given. That's the force in the rope pulling the block, right? Now, if the block is going this way, then frictional force will go this way, because frictional force opposes the path of the motion, right? So we have frictional force here, and the frictional force is equal to mu r. Does that make sense? Now, for me to solve this question, I have to resolve this force, right? And that's the force you are asked to find. But for you to find the force cannot be on the slant part like this. It cannot be between y and x. Does that make sense? So you have to resolve it towards the y-axis and towards the horizontal axis, right? So what am I going to do? Let me quickly re-strategize resolving the force. So I have my 15 kg, right? Now down here is my weight, still equals to 115 newtons, right? I have my R remaining here. So me resolving this to the side, I'm going to get F sine 35 degrees. Right. If you don't understand how I am actually resolving that, check our next video on resolution of forces. Right. So I have to the x-axis, I have F cos 35 degrees. Does that make sense? So if that's the case, I still have my FR here, my FR remaining, FR equals to mu R. Now note that R is not equal to W, despite the concrete, the surface is not inclined, but then the rope is inclined, right? Now, why did I say R is not equal to W? Because the vertical components that is equal to W are now two, this and this, right? So this is equal, W is equal to the two components. So I have W will be equal to, for vertical axis, now I'll have Fy is equal to, or Fy is given as W to be equal to, or let's have W in bracket of R plus F sine 35 degrees, right? Everything to be equal to MA that's from your Newton's equation, right? Second equation, right? So this is your net force. The whole of this is now your net force. It's not equivalent to this. Does that make sense? Now, note that I said that R is not equal to W. Why? Because if R is equal to W, it means if W is 150 newtons, R should also be 150 newtons. But there are two components that are equal to W. Let's have it. Now, note that acceleration, the body is not acceleration, hence acceleration is equal to 0. So we have W equals to the whole of this comes here, right? This becomes 0, right? If that is the case, now what am I going to have? I'm going to have R plus F sine 35 degrees. That's what W is equal to. W equals to R plus. Now, if this is 150 newtons and this is 150 newtons, this must be a value. This must give you a value, even if it is an infinitesimal value, very small, 0.0015. At this junction, even if it is as small as this, at this junction, left-hand side is not equal to right-hand side. Hence, R must be something less than 150 so that the left-hand side can be equal to right-hand side. Does that make sense, right? So if that's the case, what can I have here? I have my equation 1. Equation 1, right? Why do I need to consider equation 2? I need to consider equation 2, which is the x-axis, because the component I am looking for is F, and F is falling on both axes, right? I have y-axis here, and it's also falling. The component is also falling on x-axis. So for me to look for a value for it, I need to combine the two axes. So I have for Fx, I have Fr minus F cos 30 degrees, cos 35 degrees, right? Cos 35 degrees. Everything to be equal to NA, according to F equals to NA, right? This is my net force. The whole of this is my net force. So the body is not accelerating on this axis too. The acceleration is not given. So we're not told the body is accelerating. Hence, acceleration is equal to 0. So we have Fr to be equals to F cos 35 degrees. Hence, because this guy is going to tend to 0. Hence, what am I going to have? This is my equation 2. So for me to solve both equations, I have from equation 1 now. Equation 1, I have W equals R plus F sine 35 degrees, right? Like this is your equation 1. So can I solve something with it? What is my W? My W is saying 150 newtons. My R is not given, so I don't have R, plus F, I don't have F, sine 35 degrees would be sine 35 degrees. So if you're looking for F, you make R the solving formula. If you're looking for R, you make F the solving formula. So I am making R my subject. So I'll be having R to be equal to 150 minus F sine 35 degrees, right? 35 degrees. So this would be my equation 1. So for me to get my equation 2. Equation 2 solved, I'm going to have FR. So from equation 2 now, equation 2 is telling me FR equals to F cos 35 degrees. That's my equation 2. So FR is still the same thing. Since I don't have a value for FR, let me quickly turn it there. It's still the same thing as mu R, F cos 35 degrees, right? Make R the subject. So we have R equals to F cos 35 degrees, right? Over mu. My mu is given as F cos 35 degrees. Mu is given as 0.15. So I have over 0.15, right? So what will be my value for cos 35 degrees divided by 0.15? I'll have 5.46. 5.46. So R will be equal to 5.4646 F, right? This is my value for R. And I could just substitute that value of R into equation 1. So from equation 1 now, what am I going to get? I'm going to get R is equals to 150, right? Minus F sine 35 degrees. That's still my equation 1, right? So what is R? R is telling me 5.46 F equals to 150 minus F sine 35 degrees, right? So I'll have 150 equals 5.46 F plus F sine 35 degrees. Sine 35 degrees. Right. So if that's the case, what will be my value? Sine 35 is 0.5735. That's 36 equals 5.46, right? F plus 0.5736, 150. If the other term is going to give me 5.46, right? That will give me 6.03. 6.03 equals to 150. F, right? F. So 150 divided by that, I'm going to get 150. Like the answer, so we have our force to be equals to 150 over 6.03, right? That will give us 24.86 newtons, right? For this question, question says a horizontal force of 25 newton applied to a block of mass 9 kg is just sufficient to move it. So we have a force of 25 newton applied to this mass, and it is sufficient to move it if, right, the crate is now pulled at an angle of 40 degrees to the horizontal. Find the force required to move the crate over the horizontal surface. So the what if there is a conditional statement and a statement standing on its own, right? So, but there are two cases in this question. The first case is when the block was pulled by this force. And the second case is when it was now pulled at an angle of 40 degrees, right? These are the two cases in this question. For this kind of question, one case, the first case usually is dependent on the second. So you must be looking for something that is connected to the other question, right? So let's take the first case. So I have case 1. For case 1, I have a horizontal block, right, of 9 kg is pulled by a force to the side, 25 newtons of force. Now, note out all of the components. Don't forget your weight towards the center of the earth. That will be equal to 90 newtons. And opposite it is your normal reaction, which is still the same thing as mg, and that is equal to 90 newtons. So here, R is equivalent to W. Right. Now, opposite this would be your frictional force, right? And your frictional force Fr is equal to mu R. But don't forget that the force here, 5 newtons, is sufficient to move it. So it is likely that the force is equal or greater than the frictional force. All right. If that was the case, can we look for the missing component? The missing component should be your mu. Don't forget your mu is usually between the surface and and the block, right? So your mu is the one missing here. So to find your mu, you have mu equals to FR over R. Your FR is not given, but you know at every point in time when the force is sufficient to move a block, at that point F is usually equivalent to FR. Hence, I would say it's still the same thing as F. Does that make sense? Hence, I have 25 newtons over 90 newtons, right? That would give me 0.27. 0.277. So I have 0.28, right? This comes up, right? This is my mu. This mu, we're saying now, should be what is connecting this first case to the second case. So for second case, the question says if the crate is now pulled at an angle, so I have case 2. So for the crate to be pulled at an angle of 40 degrees, so I have still the same 9 kg, right? The crate was not changed, neither is the surface changed. Hence, the coefficient of friction between them still remains the same. So I have my coefficient of friction to be equal to 0.28. The weight still the same as mg's. Weight does not change; it is constant, right? 90 newtons, right? Now, but note that the crate is now pulled to a particular side, right? And at an angle of 40 degrees to the horizontal. If that was the case, so I don't have the force pulling the crate towards this area, but I know my frictional force remains here, right? Since the direction of the crate is going this way, right? If that was the case, I have my frictional force to be still equal to mu r. Now, check out for other components. You have the normal reaction. The normal reaction, it won't be equal to mg here because there is a crate pulling it, and hence you have to resolve this towards this angle and towards the horizontal. Does that make sense? So resolving it towards the vertical, I'm going to have P sine 40 degrees, right? And this will be P cos 40 degrees by the time I resolve it to the horizontal, right? Now, once resolved, this disappears because it has been resolved. Does that make sense? All right. If that's settled, can we have the force solved? You were asked to find the force, and the force there is P, right? So for me to get that, don't forget your force P is on both components. So we have this and this, right? So you need equation that would include this component Fy and include this component Fs. Does that make sense? All right. If that was the case, then I have for Fy, I have W to be minus because W is facing downwards. The two here are facing upwards, right? So I have minus in bracket of P plus R plus P sine 40 degrees, right? Everything to be equal to MA because we are actually getting that from F equals to MA, which this whole of this is representing your net force F, right? Right. So if that was the case, note that acceleration is equal to 0 because the body is not accelerating. Hence, I have W to be equal to R plus P sine 40 degrees, right? So this is my value, but I know that W is equal to 90, so I have R is not equal to 90, right? Note that R is not equivalent to W, right? So it's not equivalent to it, right? So we have not equivalent, right? So we have R plus P sine 40. Sine 40 would give us 0.6428 on approximation. So I have P. This mark my equation 1, right? So if I have this as my equation 1, then I get the second part of the equation. The second part of the equation that would be for Fx, right? So I have Fx. I'm going to get still from F equals to Ma. Does that make sense? Now this is facing the side. This is dragging it this side, right? So it will be subtraction of P cos 40 degrees minus Fr, everything to be equal to Ma, where the whole of this represents F, right? If that was the case, what is my cos 40? Cos 40 is 0.7660. So I have 0.7660 P minus Fr everything to be equal to 0 because acceleration is equal to 0. Does that make sense? So I have 0. So I'm going to have FR to be equal to 0.7660p, right? Equals FR. No, equals that, right? FR equals this. So I have mu R to be equal to 0.7660p. What's my mu? My mu is given as 0.28. So I have 0.28 R, right, equals to 0.7660p. So I can make, once you're looking for P, make R the solid formula. You're looking for R, make P the solid formula. So I'm making R the solid formula because I'm looking for P. Hence I have 0.7660p, right, over 0.28. So what am I going to do? So I have 2.736 on approximation. 2.73. Let me have it as 2.7359 on approximation, right? So this is my P, right? This is my R. So let me call it equation 3. Now substitute equation 3 into equation 1. Okay, this should be my equation 2. Right? So substitute equation 2 into equation 1. What am I going to have? I will have substitute 2.7359p for R, right, in equation 1, right? What's my equation 1? My equation 1 says 90 equals to R plus 0.6428p, right? This is my equation 1. So bringing this into this, right? So what am I going to have? I'll have 90 equals to 2.7359p plus 0.6428p, right? That's correct as that. So I have 2.7359 plus 0.6428. That's 3.3787p equals 90. So P would be equals to 90 over this, right? 3.3787, right? So in the end, I have P to be equals to 6.64 Newton. So the amount of force that is dragging this at that time, that's dragging this here at that time is equals to 26.64 newtons, right? That's that for this question. The next question says, a 50 kilogram mass of block is at the point of sliding down, plane inclined at 30 degrees. So we have a plane is inclined at 30 degrees, right? So this is your angle, right? So the horizontal. Find the least force. We have a block of mass 50 kg, right? Find the least force parallel to the plane required to make the object to begin to slide up the plane. So you're looking for a force to make the object to slide up. So let's have the force as F. So this is what you are looking for, right? Now, if that's that, here would be your position. Note that there is always a constant here bringing the object down irrespective of the direction of the force, right? So, but then you have your frictional force missing. So if the force in motion, because the force you're asked to find is the force that would bring this object up, hence is the force in motion. So opposite the force in motion, frictional force must be opposite. So you have your FR here, and don't forget your FR would be equals to, now if you look mu R, right? If your force is here, right, your frictional force must be opposite it, because frictional force is that force that opposes motion. So if that's the case, I have my horizontal component W cos theta, right? I have opposite it is my no reaction, right? So I have R. Here, R is not equivalent to W because the body is inclined. So you have your W to be equal to mg, right? And your W will be equal to 500 newtons. That's correct. Now, let's have the force found. We have F would be equal to, for this axis, right? So this axis is your Fy, and for this axis, you have F to be equal to the addition of both on the other side. So you have F to be equals to, or let's take it from Newton's equation of motion, since that has always been our background. So we have this our net force, right? Net force. So you take in the forces on that axis. So you have W sine theta, right, plus FR minus, right, the whole of this minus F equals to NA. We're not told that the body is accelerating, hence acceleration is equals to 0, right? In that case, you have F to be equals to W sine theta plus FR. For reflection, this literally means that for this force to be able to, or for anybody to be able to pull this object down or up the plane, right, the person must be able to overcome these two forces, both the frictional force that will be pulling the object backward and the weight of the body downwards. Do you get that? So that is the explanation step. So we have our fx axis. So if this is our equation 1, we have our fx axis, right? We have r to be equals to w sine theta, no w cos theta, provided that the body is not accelerating in that direction. Does that make sense? All right. Can we quickly find solution to the problem? So we have from equation 1, right? From your equation 1, you have f to be equals to w sine, our w sine theta plus fr. Your w, this is your equation 1. So your w is equals to 500 sine 30 degrees plus fr is not given, but we have it as our mu r, right? So if that is the case, can we quickly find 500 sine 30 and 30 is 0.5, and 500, that will give us 250 plus our mu. What's the value for our mu? All right, we don't have a value for mu. So what you just have to do is very simple. Mu would be equal to tan 30 degrees, right? So I have tan 30, this gives me 0.58. So that will be your mu, right? So quickly, you have 0.58. That is equals to your F. So we don't have R, so that's the equation 1, still equation 1. So from Fx, from equation 2 now, we have equation 2, we have R to be equals to W cos 30 degrees. So what's our W? 500, right? Cos 30 degrees. That's going to give you 433 newtons, right? So can we impute that into this position here? So we're going to have F to be equals to 250 plus 0.58 into bracket of 433, right? Equals 250 plus 433.58, right? If that is the case, we'll end up having 683.58, right? That is the force required to bring the object off the plane. Right. For this question, the question says a body of mass 20 kg moving at 6 meters per second on a rough horizontal floor is brought to rest after sliding through a distance of 5 meters on the floor. Calculate the coefficient of sliding friction. So to solve that, we have this is a horizontal floor, but it's actually a rough and horizontal floor. So I would represent the roughness, its roughness, with this, right? This, and this. That's correct. So what do I have here? I have a mass of 20 kg sliding on the body, on the rough body. So I have a force pulling it to this angle, right? And it's brought to rest. So if it's brought to rest, then don't forget it's moving at 6 meters per second. So I have my initial velocity to be equal to 6 meters per second. My final velocity is good as rest. It is equal to 0, right? Then a distance is covered between this and this. And distance is said to be S equals to 5 meters, right? If that's the case, note that if the force is dragging it to mu r. Right. So if that is done, then we have the mu found. The mu is equal to Fr over r. But note that the body is sliding, hence at that point, Earth in motion is almost equivalent to Fr, or is either equivalent or a bit higher than it. Do you understand? That is when the body can move. Does that make sense? But we usually take it as being equivalent. So what we have, if I cannot get my Fr, because I cannot actually get my Fr because I don't have mu. I have r, but I don't have mu. So there are two unknowns there. Now, how can I look for my mu? I can use tan theta, but there is no angle given, right? So that makes this a bit tricky. So what am I going to have? I will have Fr, but I know that Fr is equivalent to F. So I can, instead of looking for my Fr, I can look for my F, which is usually equals to NA, right? So for me to look for my F, but I have F to be equal to NA. So I have my mass to be 20 kg. What's my acceleration? I don't know. But I can find my acceleration because I am giving equations, I'm giving parameters for equations of motion. So I have my final velocity to equal to 0, my initial velocity to be equal to 6 meters per second square, per second rather. So I have this to be equal to 0 meters per second, right? So if that is the case, I have f to be equal to 5 meters, and that's all, no time. So which of the equations of motion best suits that? I have v equals to u plus at. I have s equals to ut plus half at squared, right? I have v squared, that's the fourth equation of motion, plus 2as, right? So this cannot be used, this cannot be used because I don't have time for the two. But I can use this, the fourth equation of motion, we have f equals to u plus v over 2 into bracket of c, right? I can not still use this, but this is best for me because I have all the parameters. Hence, I can have the whole of this used, right? So I can have v squared equals to u squared plus 2as, right? So if that's the case, I have 0 squared equals u 6 squared plus 2 into bracket of 5, right? If that's the case, I will have 36 plus 10a. So I have a to be equals minus 36 over 10, right? That will give me minus 3.6 meters per second squared. That's my acceleration. So how can I get my force? I have force equals ma, right? So I can have my mass to be 20 times 3.6 meters. You don't need to add the minus because this tells you deceleration. It only signifies deceleration. You understand now? But what you actually need is the acceleration. That's 3.6. So what do I have? I have 20 times 3.6. That's giving me 72 newtons, right? So therefore, what will happen to my mu? Therefore, I can have my mu to be equal to Fr, right? Still the same thing as F. Does that make sense? Over R, right? Over R. So what am I going to have? I'm going to have 72 over my normal reaction. It should be around here. My normal reaction is given as 20 newtons, no, 200 newtons, right? Because 20 times 10, right? Since my weight 2 is equals to 200 newtons, that's your mg, right? Here, R is equivalent to W. Does that make sense? All right, so I have over 200 newtons. So what will that give me? I'm going to have 0.36. 0.36 no units, right? So that is my answer for mu. All right, that's that for this question.